Arcs and angles. Does anybody know the type of angle that we talked about last week? The central angle. Perfect. So right here, when we draw it out, we have a central angle. And what type of lines were made? Y'all don't have to write this down because this is like not really on y'all's paper. This is a blank piece of paper I have. We're just reviewing. So that right there, we call that a central angle. Why? The vertex is at the center point, right? That angle is actually made. So this is a central angle. And then when in between the sides of the angle, we have something called an arc. Okay? We call this like an intercepted arc, meaning that when our lines intercept the edge or intersect the edge, we make an arc. What was the relationship between this angle right here, the central angle, and the arc? So like if this measure right here was 60 degrees, what would be the measure of my arc?
60 degrees.
It's 60 degrees. The arc and the angle have the same exact measure. That's only true for central angles, okay? So we have an arc. What type of arc is this?
Minor.
It's a minor arc because it's small. So we have a minor arc. And then on the other side of this, we have what type of arc is this? Major arc. How would we find the degree of this arc? Right, we take 360 and we subtract 360 from it. So that would be kind of that relationship. Okay, today what we're going to introduce is a inscribed angle. Now, let's say we still have our points right here, but instead of it being the vertex being at the center, our vertex is actually on the edge of the circle across from the arc. Now, this angle that's made right here, is that smaller or bigger than my central angle? It's smaller, okay? So this is going to have a different relationship than the central angle has with the arc. So the arc and the central angle are equal. Those are equal to each other. But for this, our inscribed angle would be 30 degrees. So what's the relationship between the angle and the arc now?
Half.
It's half. So with a central angle, it's equal. With an inscribed, it's half of the arc. Okay? So that's just kind of like an intro. So now we're going to go over here to our actual like notes for inscribed angle. So an inscribed angle is an angle with the vertex. Where does this vertex in regards to the circle? It's not at the center, it's where? It's on the edge, right? So right there we would say on this circle with the two sides that are, what type of lines are like BC and AB? Those are chords. So with a central angle, your sides are radii. For an inscribed, your sides are chords. If you would like kind of just to have like a little note, right here, the central angle is P to A and P to C. That right there is what we call a central angle. B, when it's on the circle, is an inscribed. And then again, right here, we have our arc that's made by both of them. What's the name of that arc right there that I just highlighted? AC, because it goes from A to C. Remember with arcs, we take the shortest route, okay? So if we go from A to C, we're going to take the shortest route. If I wanted to go the long way, how would I change the name? It would be ABC because I'm going from A, I hit B, and then I hit C. So that's how you know whether you're taking the minor arc or if you're going with the major arc. Okay, so the intercepted arc is an arc that lies between the sides of an inscribed angle. And then we just talked about how the inscribed angle is, when we're actually finding that degree, it is half of the measure of the arc. So over here we have ABC. we would say to find the measure of ABC, we're going to find half of measure of arc AC. So again, connecting this to central angles, inscribed angles, they have different relationships with the arc, but they both make an arc. Okay, do we have any questions?
No, ma'am.
Okay.
Just give me a moment to write.
Okay, so now let's go to when it says it intercepts a diameter. In this picture, what is my diameter? BC. It's a line that goes through it. It goes through the center, so that's your diameter right here. Now, the angle that is made with this diameter, what is the actual inscribed angle? BAC, right? So we start here at B, we go to A, that's the vertex, it's on the circle, and then we go up to C. Now, the ends are at the ends of your diameter. So that means that this is the arc that's across from angle A, my inscribed angle, right? So what's the degree of that arc if it's made by a diameter? What's the degree of the arc?
180.
The arc is going to be 180 degrees because it's a what's the name of the arc? What's 180?
Semicircle.
It's a semicircle. So that arc right there is 180 degrees. So now that means that the angle is how many degrees?
180.
No, because it's not equal. It's half of the arc. So right there, if I want to do the angle, I would do 180 divided by 2. I take my arc, divide that by 2 to get 90. So that means that this inscribed angle would be 90. Now, this angle right here, not the length of the line of the diameter, but if I'm looking for that angle at the center is 180. But that's, again, 180 is just like the degree of a straight line. So right here, if an inscribed angle intercepts a diameter, then it is a right angle. And that means the measure of angle BAC is 90 degrees. Okay, and the last thing we're going to look at is if two inscribed angles intercept the same arc. So an example of this would be right here. If I'm looking at angle B, I'm looking at A, B, and then we go to D. What arc goes with that angle right there? AD, right? This arc right here. Well, then if I go the other direction, what if I said, okay, I'm going to do A, instead of going to B, I go C, and then I go D. It makes the same arc, right? So if two angles share an arc, what does that tell you about those two angles?
They're equal.
They're going to be congruent. They're going to be equal because they're half of the same arc. So angle B and angle C are equal because they both share AD. But then if we look over here, if we look at angle A, this angle right here, and angle D, this angle right here, that shares the arc BC, the one across from that. So that means that angle A and D are also congruent because they share the same arc. So if two inscribed angles share the same arc, that's the key right there, then the angles are congruent. And we can say the measure of angle ABD, again, B is the vertex, is going to be congruent to measure of angle ACD. And again, C is that vertex. Okay, so those are all of our rules, just kind of like intro for inscribed angles. If you have two angles that are on the same side, share an arc, they're congruent. If you have an inscribed angle that's made by a semicircle or a diameter, that's always going to be a 90-degree angle. And then your inscribed angle is always half of your arc. Okay, so now let's look down here, and I just kind of want to show you. I'm not going to go through this one right here, but what I want to show you is that like people were getting this wrong yesterday when I did this with second period, because right here, BC, that's the arc we're looking for, right? But 47 doesn't go with BC. What does 47 go with? But what arc is that finding? It's finding AC. So, yes, that's the right process, but we have to find AC first, then we find BC. But you have to be careful, because what people were doing is they were finding AC, they were writing that number down because they were not reading what the question was actually asking you for. And the question's asking you for BC, not AC. So be careful about those little details when you're when you're solving problems, okay? Same thing kind of like on number 5. What arc goes with angle K right here?
LMJ.
LMJ, it's a big arc, so we have to do all 3. Do I know that one? Don't tell me how to find it, but do I know that? No, so you have to find it before you can find the angle. So be careful about those little details when you're doing problems like this. Okay, so now you're going to go to this page right here. This is like very short. This is like a small little piece of information that we're going to go over. So we have an inscribed quadrilateral. What's a quadrilateral? 4 sides, right? It doesn't have to be a square. It doesn't have to be a trapezoid. It doesn't have to be anything. It just has to have 4 sides. So right here, this could be a trapezoid. I don't know, because this and this look parallel, but nothing tells me that it is parallel. So I can't assume that it's parallel. All I know is that it's a quadrilateral. And what we know about quadrilaterals, for it to be inscribed, is that every single corner of my quadrilateral has to be on the edge of the circle. So B, A, C, D, all of these are actually on the circle.
They all have to be made up of chords.
Yeah, it has to be made up of chords. Perfect. That's what an inscribed quadrilateral or any type of inscribed shape means, that all vertices of that shape are on the circle. Now, the best example I can kind of show you on this is right here. If you look at B and you look at D, are those the same? Are those equal to each other? No. So the rule that we're going to be looking at is opposite angles. So B is opposite of what? D. What is C opposite of? A. Now, they have a relationship that's always true, okay? It's not that they're congruent. What is always true is that they are always going to be supplementary. What does supplementary mean? Add up to 180 degrees. So right there, B and D, they're not equal, but if I did measure of angle B plus measure of angle D, that should equal what? 180. If I wanted to know anything about A or C, I would use the relationship measure of angle A plus measure of angle C equals 180 degrees. So opposite angles are always supplementary. We don't know if they're congruent. We never know if they're the same. For example, over here, all 4 of these could be different angles. Okay? All 4 of those are different angles, and so we go like that. Okay. I do want to do one example on here because I don't think this is just like naturally something we visualize or see. Number 2, pretty straightforward, because if I want to find Q, it's opposite of S. I can kind of play around with that. But over here, what is opposite of B? D. What is opposite of A? C. But do I know anything for B or D? Do I know anything for A or C? No, they don't give me any degrees, so I can't really just subtract from 180 to find the other one. I'm going to have to do a little bit more work. What is the only information they give me for this problem?
Some arcs.
They give you some arcs, right? In fact, they give us 3 arcs. They give us 39, 61, 147. So we have to figure that out. This is where the inscribed angle part comes in. So right here, if I'm looking at the inscribed angle for D, I'm going to kind of expand this. So I have this arc and I have this arc. So what arc would I use to find the measure of angle D? ABC. So I have this whole arc right here, right? So what's the degree of that arc?
100.
It's 100 because 31 plus 61 is 100. So if that is 100, how do I find angle D? Divide it by 2, which is 50. So right there, I know that angle D is 50 degrees. If I know that D is 50, how could I find B? It's easier than that. What's the relationship between opposite angles? Subtract 180. Opposite angles are supplementary, right? So if I know that D is 50 for angle B, I can just do 180 minus 50, which gets me 30 degrees.
Wait, Miss Flores?
Mm-hmm.
How much of the homework did you do?
Hold on. Then,
Wait, Miss, how does 180 minus 50 equal 30?
oh, it's 130. It's 130, sorry. 130. Okay. So then we're looking at A and C. Which one can I actually use the arcs to find? A or C? A. So if I take that, I'm going to go A right here. And then I come out and I expand A right here. What 2 arcs are A using? B to D. So I start with B, which is the 61. Now, one thing I want you to be very careful about, because this is what people keep forgetting. You go around the circle. So I go B, C, and then I go around to D. That's my whole arc right there.
61 plus 140.
Well, we did find B. But now I can't use either one of these to find A or C, because these don't have a relationship with A or C. Hmm?
You just do ACD and then have 147 and then divide that by 1.
Well, but we have to include the 61. We can't include the A. It's just B to here. So it's 61 plus 47, which is...
Oh, I see what you mean.
So if I go right here, this is the arc that I'm going to use. 61 plus 47 is 208. So if I do half of 208, that's going to get me A right here, which is what?
104.
This is 104. So A is 104. And then I'm going to do 180 minus 104 to get you 76 over here. So this one has a little bit more work than just, hey, we subtract from 180. You have to use the arcs that are around it. So that's the one thing with circles, you always want to be looking at. What information does that problem actually give me, and how can I use it? Okay? So just remember, we have one more day of notes, we have 2 days of review, and we have test on Tuesday. Okay?